Here are the answers for the section 6-7 word problems assignment. On page 240, we have question 1. The stone is tossed upward with this initial velocity from a height of 700 feet above the surface of planet Mars. The height h above the surface, t seconds later, is given by this math formula. Determine the maximum height reached by the stone. This situation relates to our current topic of quadratic functions because the trajectory of the stone is a parabola. If you're standing on the surface of Mars and a person throws a stone into the air, it would go up and then slow down and then come back down until it strikes the surface again. The maximum height of the stone would be found at that dot right there called the vertex. So this question is about finding the vertex. Let's take a look at our quadratic equation. What form is it in? Is it in vertex form or standard form? It's in standard form, and we see that A is negative 5.6, B is 112, and C is 700. To find the y value of the vertex, we use the formula C minus B squared over 4A. So let's make our substitutions. Put 700 in for C, put 112 in for B, divided by 4 times negative 5.6. Now this is simply a matter of typing this in the calculator. The answer for the y value of the vertex point is 1,260. And that y value is representing height, which is measured in feet in this question. So here's the maximum height of a stone thrown on planet Mars. Number 3, if the point 8, 0 is an element of this set, what is the least value of this function? If we know that 8, 0 is a solution to the equation, then when x is 8, y is 0. Let's make those substitutions. 0 equals b times 8 plus 8 squared. This is 0 equals 8b plus 64. We can solve this equation to find that b is negative 8. Now that we know the answer for b, let's rewrite our original equation. It's y equals negative 8x plus x squared. We want to know what is the least value, meaning what is the smallest answer we ever get for y using all numbers between 0 and 8 for x. One way to figure that out is to graph this function and then look to see where is the minimum value. This is a quadratic function, but we're used to having the x squared term first and then the x term. This is in standard form. The value of A is 1. The value of B is negative 8. And the value of C is a 0. Because the value of A is positive, the vertex is a minimum point. That is that the parabola, when you graph it, is this type here that opens up. And the vertex is the lowest point on there. Let's find that vertex point. Its x-coordinate is given by negative b over 2a. The negative of negative 8 is 8, and 2 times 1 is 2. And so x equals 4. Notice that x equals 4 is within the interval that we're supposed to consider. What is the value of y when x equals 4? To find the y-coordinate of the vertex, we can use a formula, or we can substitute in 4 for x. Negative 8 times 4 is negative 32. 4 squared is 16. And these add together to make negative 16. The least value of y on the parabola is located at the vertex, and it is negative 16. Number 5. A missile fired from a launching pad follows a path whose equation is y equals x minus 3.125 times 10 to the negative 6 power x squared. This is a quadratic equation because of the x squared term. Let's find the maximum altitude attained. The maximum value is located at the vertex. The maximum value is the y-coordinate of the vertex. Well, let's figure out what that is. The first thing I'm going to do, though, is rearrange my equation so that the x squared term is first, because that's what we're used to. So this is negative 3.125 times 10 to the negative 6th power x squared. Then the plus x. This is in standard form. And this value in front of x squared is our a value. In front of the x, we see that b equals 1. In the constant, we see that c equals 0. We want to find the maximum altitude. That is the y value of the vertex point. We have a formula to find that. C minus b squared over 4a. So 0 minus 1 squared over 4 times that value of a. The fact that that's in scientific notation, don't let that bother you. Your calculator can handle that. You just need to type this in. 0 minus 1 squared, divide, and then put all of this denominator in parentheses. Make sure you include parentheses around that when you type it in the calculator. This turns out to be 80,000. The letter y is representing the height, and we're told that that's in feet. So the maximum altitude is 80,000 feet. Now, question B, what is the distance from the launching pad to the point of impact? How far is it across here? One way to find the answer is to recognize that the x-coordinate of the vertex is half the distance to the point of impact. So if we find the x value of the vertex, we could then double that to figure out what x equals over here. We have a formula to get the x-coordinate of the vertex. Negative b divided by 2a. So this is negative 1 divided by 2 times that value of a. Again, when you type this in the calculator so that the calculator knows that 2 is in the denominator and this number is in the denominator, you must put that in parentheses. The x-coordinate of the vertex is 160,000. In the drawing, that's the x-coordinate of this vertex dot. If you go straight down to touch the x-axis, that means that this mark on the x-axis is at 160,000. But we want to know what is this x-coordinate, where the missile hits the ground. So let's double our 160,000. We just need to times it by 2. And we get 320,000 feet. For the review assignment, we're going back to page 240 where we were graphing parabolas. Number 11, this is in standard form. Here's A and B and C. Let's figure out the x-coordinate of the vertex with the formula negative b over 2a. This becomes positive 12 over 2 times 2. And this turns out to be a 3. So when you make your xy table, the middle row of the table will be the point 3, comma, something. To find the y value of the vertex, substitute 3 into this equation. 3 squared is 9. 2 times 9 is 18. Minus 12 times 3 is 36. And then add 20. Let's see what this makes on the calculator. It makes 2. So the vertex is 3, comma 2. Now let's get some other dots by choosing 2 and 1 and 4 and 5. Let's plug in 4 into the formula. 4 squared is 16, and 2 times 16 is 32. Minus 12 times 4 is 48, and then plus 20. This makes positive 4. And assuming that we haven't messed that one up, then this will be positive 4. Now let's substitute in 5. 5 squared is 25, and 2 times 25 makes 50. 12 times 5 is 60, and then add 20. Let's see what this makes. This makes 10, and then this would be 10. Now that we know those values, we can graph our parabola. For the points that I chose, I never got any negative y values. So I'm going to draw my axis system like this, just to save space and time. I'm not going to go down here and do any negative marks. On the x-axis, I've selected numbers from 1 through 5. 1, 2, 3, 4, 5. Certainly you can put more marks on there, but it's not necessary to get the parabola on. The highest y value I ever got was 10, so I want to have at least 10 marks going up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now let's graph our dots. Here's 1, 10, 2, 4, 3, 2, 4, 4, and 5, 10. And draw in the parabola. Number 13. I'm going to rewrite this so that the x squared term comes first. Now I can figure out that a is -1, that b is 4, and that c is 0. To get the x-coordinate of the vertex, the formula is -b over 2a. So -4 over 2 times -1. This makes 2. Now make an xy table. And in the middle row, put x is 2. Now get the y value of the vertex by substituting 2 into the equation. 4 times 2 is 8, minus 2 squared is 4. This turns out to be 4. The vertex is at 2, 4. Then choose numbers to the left and to the right. Okay, I'm going to plug in 3. 4 times 3 is 12, and 3 squared is 9. This makes 3, and so will this. Now I'm going to plug in 4. 4 times 4 is 16, and 4 squared is 16. This makes 0, and so will this. Now let's graph this. Notice that we never got a y value that was negative. So when I draw my axis system, I don't really need to go downwards to the negatives. On the x-axis, my numbers go from 0 through 4. So 1, 2, 3, and 4. On the y-axis, the highest number I ever got was positive 4. 1, 2, 3, 4. Let's graph the dots. Here's 0, 0, 1, 3, 2, 4, 3, 3, and 4, 0. And then draw in the parabola. On page 212, we're asked to give the range of the function and then graph the function. One thing I notice is that this is not a quadratic equation. It doesn't go to the second power. The x and the y both go to the first power. This is linear. Another thing I notice is the inequality symbol. We're going to graph a solid line and then shade one side or the other. Now we're not used to our inequalities having the letter x on the left side. We're used to that being the letter y. Let's rearrange this by subtracting 2y to both sides. We get x minus 2y is greater than or equal to -3. Now subtract x from both sides. We get -2y is greater than or equal to -x minus 3. Then divide by -2. The arrow switches when dividing by a negative. We get 1/2 x plus 3/2. Knowing that I'm going to graph this, I'm going to write 3/2 as 1.5. This is slope-intercept form. This is our slope value. This is our y-intercept. So let's make a quick grid and graph this. The y-intercept is 1.5. So between 1 and 2, put a dot. The slope is up 1 over 2. So up 1 unit, I'm halfway between these marks, and then over 2 units. Here's another dot. There is an equals bar, so this is a solid line. And this is a is less than symbol, so you shade underneath the line. We're asked to give the range of this. what are all the y values that would be covered by this shaded in section? Because the line continues forever downwards, you're going to end up shading forever in the negative direction. But because the line also continues up forever, eventually you'll be shading upwards in the positive direction to infinity. So the range is all real numbers. Number 6, let's give the range and graph it. Remember that range is all your y values. Well, there is only one y value that we can have. Y equals -1. That's our range. Now let's graph it. This is a special case line. Y equals -1 is telling us it's crossing the y-axis at -1. So it is a horizontal line. Every dot on the line has a y value of -1. Page 215, we have a function formula for function p. We're asked to evaluate function p when x is 3. So fill in 3 where the x is. This is 9, take away 6, which is 3, plus 1 is 4. Same function rule, but fill in a squared. So for where the x is, fill in a squared. Right, where that x is right there, put an a squared there. Then minus 2 times a squared. Where that x is, put in a squared. And then on the end, plus 1. Now let's simplify this up. A squared to the second power is a to the fourth. And then we have -2a squared, and then plus 1. Number 22, give the domain and a formula for t of x. Domain is all of the x values. So our domain is 1 and 2 and 3 and 4. Now let's make an equation that shows how to find t of x. Let's check if this function is a linear or a quadratic function, because those are the ones we've studied so far. To check if it's linear, we have to have a constant rate of change. When x changes by 1, this changes by 3. When this changes by 1, this changes by 3. When this changes by 1, this changes by 3. The rate of change is always this one changing by 3 when this one changes by 1. That's a constant rate of change, so it is linear. To find an equation for a linear function, we know the point-slope formula. Y minus y1 equals m times x minus x1. And as our y1 and our x1, we can use this first ordered pair, 1, 5. So y minus 5 equals, now the rate of change. Remember how y changes by 3 when x changes by 1? So that's 3. And then x minus 1. Let's get the letter y alone by adding the 5 to the other side. 3 times x is 3x. 3 times -1 is -3. And when you add 5 to that, you get +2. Here is an equation, but it uses the letter y and the letter x. And we don't want to use the letter y. We want to use t of x instead of y. But that's an easy fix. T of x equals 3x plus 2. Number 28. Here's a function rule for r and a function rule for t. And we're doing a composition of functions where you input one function into the other. Work from the inside out. First, figure out t is 0 by using the rule for t and substituting 0 in place of x. This makes 1 squared, which is 1. So this part inside the parentheses for r turns out to be a 1. So now let's find r of 1. Choose the rule for r and fill a 1 in for the x. And this answer makes 2. Page 220. We're given a table with ordered pairs, and we're asked, is there a linear function? We just did one that was similar. To know if there's a linear function, you check to see if there's a constant rate of change. This changes by 2 when this changes by 5. This is 2, this is 5. This is 2, this is 5. The rate of change of y compared to the rate of change of x is that y changes by 5 units every time x changes by 2 units. That happens every dot. So the answer to this question is yes, there is a linear. The slope is the 5/2. To know if it's a direct variation, our linear function has to have 0 as the y-intercept. It has to follow this basic pattern. If the y-intercept on the end, however, is not a 0, then it is not a direct variation. So let's use the point-slope formula again and see what our equation turns out to be. Here's the point-slope formula, and we can use this first-ordered pair as our x1 and y1. So y minus 10 equals 5/2 times x minus 4. Let's rearrange this and see if it ends up making this pattern, or if we get some other number on the end for the y-intercept. So first step, distributive property. 5/2 x minus, and then 5/2 times 4 is 10. Now add 10 to both sides. And -10 add 10 makes a 0. So because the y-intercept is 0, this is a direct variation. We can answer that yes. Page 221, we're told that y is proportional to 3x plus 5. That means there's an equation, y equals some number times the 3x plus 5. To figure out what that number is, let's substitute 14 for y and substitute 3 for x. And then solve this. 14 equals m times 3 times 3 is 9, and 9 plus 5 is 14. So m equals 1. Let's rewrite our equation now that we know that m is 1. Then we're asked to find x when y is -7. So fill in -7 for y and figure out what the x would be. If you subtract 5 from both sides, we get -12 equals 3x. And then divide by 3 on both sides, we get x equals -4. Page 225, we're asked to graph a step function, a function that's defined in pieces. There are 3 distinct pieces. Sometimes the value of the function is 1, but only when x is greater than 0. So on the graph, let's go up to where f is 1 and mark that with an open dot. There's not a closed dot at 1 because this definition says that it's only equal to 1 when x is greater than 0, not when x is 0. Then draw a horizontal ray pointing to the right forever. Now let's do this middle row. Put a dot at 0 when x is 0. Now let's do this last one. When x is less than 0, there's a dot at -4. So I'm going to mark it with an open dot and then draw a horizontal ray pointing to the left. Page 229, here's a function rule for g. Is this ordered pair a solution? Let's use substitution to find out. This is our g of x value, and this is our x value. So for g of x, fill in -3. For x, fill in -3. Now find out if the left side is equal to the right side. -3 squared makes +9. 1/3 times 9 is +3. So this answer is no. Let's try this next one. For g of x, fill in 3. When you fill in -3 for x, -3 squared is +9, and 1/3 times 9 is 3. So this answer is yes. Page 235, we have a quadratic equation. This is closer to being in vertex form than it is in standard form. As long as we fix that plus sign, we'll have vertex form. Let's do that first. This is x minus -9. Now we know the value of A, we know the value of H, and we know the value of K. We're asked for the equation of the axis of symmetry. The general pattern is x equals h. So our answer is x equals -9. We're asked for the vertex. The general pattern is h comma k. So our answer is -9 comma -1/3. We're asked, is that vertex a minimum or maximum? You look at the value of a. In our case, a is -1/2. When a is a negative number, the vertex is a maximum. The reason why is because when a is negative, the parabola looks like this, and the vertex is the highest point on the parabola. Next, we're asked, what is the y value at that vertex? Well, that's the value of k, because that's what k is. K is the y value of the vertex. And so that answer is -1/3. Number 17, the point -3, is on a parabola, and the axis is given by this equation. We're not used to our equation looking like that, so let's subtract the 1 and get x equals -1. That's what we're used to seeing for an axis of symmetry. Let's graph this. Okay, next, find the point -3, 0. 1, 2, 3. Here it is. The axis of symmetry splits the parabola in half. So if one dot is 2 units to the left of the axis, there is a corresponding dot 2 units to the right of the axis. This is at 1, 0. That's the other point on the parabola. Page 240, we're asked to graph a parabola. This is closer to being standard form than it is vertex form. So A is 1, B is 6, and C is 0. Let's get the x-coordinate of the vertex with this formula. So the negative of B divided by 2 times 1. That makes -3. The middle row of our chart will use -3 for x. Let's plug in -3 into the formula to get y figured out. -3 squared is 9, and 6 times -3 is -18. This makes -9. Now let's use -4 and -5 as numbers to the left of -3, and use -2 and -1 as numbers to the right of -3. Let's fill in -2. -2 squared is 4, and 6 times -2 is -12. This makes -8, and so is this. Now let's fill in -1. -1 squared is 1, and 6 times -1 is -6. This makes -5, and so is this. Now we can graph them. Notice that all of my x values in my chart are negative numbers, and so are my y values. So when I draw my axis system, I want to pay more attention to the negative parts of those lines. On my x-axis, I need to count at least to -5. And on the y-axis, we need to at least get down to -9. Now graph the dots. -5, -5. 1, 2, 3, 4, 5. And -1, -5 will be here. -4, -8. Down to the -8 mark. -2, -8. Right here. And the vertex, -3, -9. Here's the parabola. Number 8. This is a quadratic equation because of the second power. We expect a parabola. Is this vertex form or standard form? A equals 1, B equals 4, C equals 3. Let's get the x-coordinate of the vertex using this formula. So -4 over 2 times 1. That makes -2. We're going to make an xy chart, or technically it's an xt of x chart. and this is negative 2. To get the t of x value, plug in negative 2. So negative 2 squared makes 4. 4 times negative 2 is negative 8, and then plus 3. This is negative 1. For numbers to the left of negative 2, I'm using negative 3 and negative 4. And to the right of negative 2, negative 1 and 0. Let's plug these in. Negative 1 squared is 1. 4 times negative 1 is negative 4. And then add 3. This is 0, and so is this. Now let's put in 0. This makes 0, this makes 0, and on the end there's a 3. So this is 3, and this is 3. Let's at least get to negative 4 on the x-axis. And at least put marks up to positive 3 and down to negative 1. So negative 4 comma positive 3 is here, and 0 comma 3 is here. Negative 3 comma 0 is here, and negative 1, 0 is here. And now the vertex, negative 2, negative 1. Here's the parabola.